Why do we use electrolysis to extract aluminium? That's because aluminium is high up in the reactivity series, so that means aluminium is a reactive metal. Because it's high up. The higher you go up the reactivity series, the more reactive you are, and therefore, in order to extract it, we need a lot of energy to extract it, to get rid of the oxygen from it. Okay, so 2 marks, 1 mark for each answer there. One step here it talks about of extracting titanium involves a displacement reaction. The equation can be simplified, so a simplified version of the equation here. Explain why this can be described as a redox reaction. Okay, good question. So, if we look at the, let's look at the titanium first. So titanium here, this is a 4 plus ion. And because it's a 4 plus ion, that means, well, hang on, before we do that, let's look at what happens to it over here. On this side of the equation, the titanium turns into just titanium atoms, which means they have no charge. So my titanium has gone from having Ti4 plus to just Ti. So how do I make something that is 4 positive become something that is no charge? The way I do that is by adding 4 electrons. So for adding electrons, gaining electrons, that is an example of reduction. If we look at what's happening here to the magnesium, so there's my 2 magnesiums, the magnesium has gone from having 0 charge here to a 2 plus charge here. So if I just put an equation down for this, so here you've got Mg becoming Mg2 plus. So how do I take something that has no charge and make it positive? We do that by releasing 2 electrons. So there's the 2 electrons being released or lost. And if that's lost, then that is oxidation taking place. So explain why this is a reduction or oxidation or redox reaction. We need to say in here that the titanium ions are gaining electrons and being reduced. The magnesium atoms are losing electrons and being oxidized. And because you've got both of them happening at the same time, as both happen at the same time, this is called a redox. And let's just prove that using my example over here. So that is reduction, that is the ox. And when you convert those together, you've got redox reaction. In terms of marks, 1 mark for each of those. You could have used the equations that I've included as an alternative to writing out the sentences that we've included there. Okay, sulfate ions, it's got a formula. Which of the following is a formula for titanium sulfate containing Ti4 plus? Okay, so Ti4 plus and sulfate ions. This wants to make 4 bonds and this wants to make 2 bonds. Remember, we get that from the charge on the ion. So 4 plus means 4 bonds, 2 minus means 2. We then check these 2 numbers here. Can we simplify them? And we can. That can become 2 and that can become 1. And we then cross them over. So this would mean titanium gets a number 1. We don't need to write that down. But the sulfate, SO4, gets a number 2. So we've got to put it into brackets and hopefully that matches, and it does. One of the answers here is option C. Right, phytoextraction. Remember, phyto is Greek for plant, so that gives us a clue to what's going on here. It says phytoextraction is an alternative biological method. Give one advantage of using phytoextraction, one disadvantage, sorry, of using phytoextraction. So because we're using plants and plants take a while to grow, this is a slow process. This is a slow process, and that's why it's a disadvantage to it. You could also have talked about the fact that you need large amounts of land because you've got to grow crops over a big area in order to do this as well. But that's, for me, the key one there is knowing it's slow. Okay, copper is low down reactivity series and can be obtained from copper oxide. So how do we get copper from copper oxide? Okay, so let's just give myself an equation here. So we've got copper oxide. If I react this with carbon, because carbon is more reactive, it will form copper. And as it does that, it will release carbon dioxide. So that equation there shows me the displacement reaction that is taking place for this. So now we need to explain how to do this. So the first thing you would do is you would mix the copper oxide and carbon in a container, and then you are going to heat the mixture. Okay, you're going to let the mixture heat up, and whilst that is heating up, that reaction then will take place and copper will start to form. So we're going to get a mark for that and a mark for that to give us our